Temperature dependence of resistance. Resistivity rho of a material changes with temperature. The resistivity of the material may increase or may decrease. It all depends upon the nature of the material with temperature. Let us work for conductors. As the temperature increases, the collision increases. The electron collide with the atoms increases, thereby the relaxation time tau decreases. Because of tau decreases, resistivity increases. The relation between the relaxation time tau and resistivity is rho equals m divided by ne square tau. So let us always remember the rho resistivity inversely proportional to the relaxation time tau. Rho inversely proportional to 1 upon tau. Let us find the relation. Rho t equals rho naught 1 plus alpha t minus t naught. Rho t is the resistivity of the material at t degree Celsius. Rho naught is the resistivity of the material at 0 degree Celsius. Alpha is the temperature coefficient of resistance or resistivity. So from this relation we get alpha equals del rho divided by rho naught into del t. All these three formula are very important towards problem solving. Alpha equals del rho divided by rho naught del t. Similarly, a relation between temperature and resistance. So alpha equals del R divided by R naught into del T. Have an eye on all these formulas. For conductor, resistivity increases with increase in temperature. Let us see in graph. It's a straight line graph. Gradually it increases. For semiconductor, resistivity decreases with increase in temperature because more charge carriers are produced. Because of increase in temperature, new charge carriers, holes and electrons are created. Because of that, resistivity becomes less. So the relation in graph is a curve. It decreases. Let's go for insulator. Resistivity decreases slightly, but still it's very high. Which of the following graph represent the variation of resistivity rho with temperature? For copper. Copper is a metal. So as temperature increases, the resistivity increases. It is well shown in the graph A. So option A is correct. The others are wrong. The solids which have the negative temperature coefficient resistance. Metals, it has positive temperature coefficient resistance. As the temperature increases, the resistivity increases. Insulator, good, it has negative temperature coefficient, but the option is only insulator, but it's wrong because even semiconductor has negative temperature coefficient. So option D, let us look at option D, insulator and semiconductor. Both are having negative temperature coefficient of resistance, so it is correct. Materials where resistance decreases when temperature increases, we say it is a negative temperature coefficient. That includes insulator plus semiconductors. Specific resistance of a conductor increases with increase in temperature, increase in cross-sectional area, increase in cross-section and decrease in length. And last option, decreases in cross-sectional area. So specific resistance depends only on the nature of the material, but not on the dimension of the material. So specific resistance of a material increases with temperature is the right one, but not the other options. Specific resistance increases only with temperature for conductors. Exam tip. Remember, resistivity. It's a material property, whereas the resistance depends upon the dimension. It is the length and area property. Copper and silicon is cooled from 300 Kelvin to 60 Kelvin. The specific resistance, so the temperature decreases. The specific resistance decreases in copper but increases in silicon. So 4 options are here. So now we have to find the copper. It is a metal, so it has positive temperature coefficient of resistance. Therefore, as the temperature decreases, the copper resistivity decreases. So it is there with option A, whereas silicon is a semiconductor which has negative temperature coefficient of resistance. That means as the temperature decreases, it should have increase in resistivity. So option A is correct. Exam tip. As metals decrease in temperature, decrease in resistivity. For semiconductor, decrease in temperature, increase in resistivity. So actually, copper is a metal, therefore decrease in temperature decreases the resistivity.